Greetings, this is Advt and today I'm going to talk about game physics in advertisements. So for this activity, I have chosen the advertisement for Prada Luna Rossa Ocean Perfume range. In this advertisement, there is an engaging scene of a speedboat whizzing past the waves on an ocean on a stormy day whilst it rains and there is thick cloud cover over the ocean. In the advertisement, the man is searching for the large red moon on the horizon. So let us have a look at the advertisement. In the advertisement, there are many game physics elements which can be used as a base for implementation on a game physics engine. So there are four main elements that we will be implementing. The first is ocean surface waves, which is the main and ubiquitous element in the advertisement. This can be done using wave mesh displacement in a game physics engine. The second element is buoyancy and motion of a boat. This buoyancy can be achieved by using normal force and torque based on the waves which are made by the mesh. Along with that, the player controller can be used for motion of a boat forward and while turning. Along with this, for the atmosphere, we can use cloud systems, which are simply volumetric particle systems, and rain particle systems, which are dynamic in nature. So, to implement ocean waves and buoyancy, we use what are known as meshes, and mesh handling is taken care of by a triangulated mesh. This mesh takes into account the world position and generates at each particular point a triangle, and the triangle can be used to highlight an ocean section, and at each point the wave height can be calculated based on a Gerstner wave approximation. So here we can see in the image on the left, there is a wireframe of a mesh. A mesh is basically a large set of points interconnected by lines which are known as edges, and within them there is what are known as faces. So for each face we can have a particular texture, and this texture can be used to show the waves on the ocean. So by using the Gerstner wave approximations, we can set at each x and z coordinate a particular y value, and this y value will mimic the ocean waves. So to the right, we can see what happens when the shaded wireframe of a mesh is drawn onto the scene. So here we have used a texture. Along with that, we have used a normal map, which allows us for the lighting to bounce off the surface of the wave. And with that, we have a color shader, which takes into account the y value of each point and outputs a different color based on it. Finally, we can see the last image at the bottom, which is the final scene with the waves. This time, the difference is that along with the color shader on the waves, we also have an atmospheric shader which allows light to bounce off and mimic the color of the sky. So in this case, because the color is dark, we have a darker hue to the water. Finally, we come to the rain and cloud fog particle systems. So particle systems are basically a useful technique to make many things in a scene and have them be controlled by a single particular logic system. So a particle is any point in space which has a texture and behaves in a certain physical manner. So there are two particular particle systems here at play. One is the cloud particle system and one is the rain particle system. The cloud particle system is known as a volumetric particle system, as the main functionality is to fill up space rather than for motion. It is used for making the atmosphere look a particular way. So here for each particle there is a texture and a normal map used, which are basically simple blobs of white and grey and black, and this is done for each particle which is spawned in an area, and each of them fades in and out at each particular time step, and this causes a scene to be formed in front of the camera in the physics engine, and this takes care of the fog and the clouds. Along with that, we have a dynamic particle system which is required for rain. So the difference between a volumetric and dynamic particle system is that in a volumetric system, the space where the system is placed makes a lot of a difference, as this dictates where the particles remain and how our scene looks. Whereas in a dynamic particle system, the bounding box of the particle system can be kept anywhere in the scene, and the particles themselves can move out of the bounding box whenever required. So rain is used as a particle system where the bounding box is way up in the sky in the scene. It is out of the playable range. However, from that particular bounding box spawns particles which are long and narrow and look like rain. So droplets of rain can be configured by using a long texture, and this particular texture is then made to fall over time and gain speed while falling based on gravity. So once this falls through the atmosphere, it looks like there is actual rain that occurs. So thank you for listening to this presentation. We will now move on to the next video, which will show the actual implementation in Unity. Thank you for watching this part.